All right, everyone. Happy whatever day you're watching this. I don't know when you're watching this, Friday, Saturday, Sunday, or Monday. But this work does need to be done by Monday at midnight, so please make sure at some point you address all the parts of it. As you see, we're going to do lesson 312. Now, we are doing this in 2 days. Okay? So you are not going to do any review preview at this point. We're going to take care of review preview on Tuesday when you come into class, okay? So for this part, all you are doing is watching the video and taking notes on problem 310 and 311, okay? If you have your handout, the handout from the packet I gave you, we are going to use one of the pages from there, so it should be the very next handout. It should say 3.1.2. If you do not have the handout, if you are fully remote and don't have the handout, please print out the handout. It just makes things a whole lot easier for you if you can. If you can't, you can do it without it, but it's going to be a little bit more work, okay? I'll explain how that's going to go as soon as we're done with this. So please get out your review preview. We're going to go ahead and go over it, and so I want to make sure that you understand and can follow along here. All right, let's go to it. So here is the review preview. Now I do want to actually address problem 3.4. I know some of you said that you were struggling with 3.4, especially B and C. Here's what we had. So for part A, you had to triple x and then add 2. So if you took x and multiplied it by 3 and then added 2, you would have gotten your answers here. By the way, these are just the blanks of the inputs. So the x values would have been 7 and 100. The y values, the ones that are on the outside, are 2 and 6.5. For rule number 2, you had to multiply by 2.5. So if you multiply all your numbers by 2.5, you would have gotten your answers. And again, the input numbers are -3 and 11, and the 2 output blanks are 22.5 and 0. And then the last one, letter C, was divide by 2 and then add 1. And so your input numbers are 6 and -7, and your output are 1.5 and -4. So I just wanted to share that, okay? So for the rest of it, please pause the video. When you are done, unpause it, and we'll continue on with today's lesson. Okay, so let's go ahead. And by the way, you should have already uploaded the picture to this by Friday night at midnight. You have to have this uploaded, so hopefully you have that done, okay? All right, 312, how can I make predictions? You are still gonna need a piece of line paper, so please make sure that that you have a line paper so you can do this work on that. You're gonna use the line paper and you're gonna use a handout for this lesson, okay? So using tables, graphs, and rules to make predictions. In lesson 311, you wrote rules for patterns you found in XY tables. In this lesson, you will focus on using variables to write algebraic rules for patterns and contextual situations. You will use a graph to help you predict the output for fractional x values, and will then use a rule to predict the output when the input is too large and does not appear on the graph. I know that's a lot of information, and it's like, what on earth? Basically, we're really going to be using tables, graphs, and rules to make predictions. So as we're doing this, please think, okay? Focus on these questions. How can you write a rule without words? And some of you were really good at that already. Some of you are starting to say, hey, I can do this x plus whatever, or, you know, that's really cool. That's what we're aiming for. Second, what does x represent? And third, how can you make a prediction? Okay, that's the goal here. So here's our problem. It's John's Giant Redwood Part 1. Now, I know that before we get going there with that, some of you are like, redwood, what on earth is a redwood? So if you don't know redwood trees are some of the biggest in the world. Now, there's between the redwood and sequoias as to which ones actually are the biggest. I believe the redwoods are the tallest trees in the world, and sequoia are the biggest ones. And so I want you to actually take a minute here and show you something about the redwoods here. So if you'll bear with me, here's a video from National Geographic. And what I want you to note is just the sheer length or size of this tree. So it's only a 1 minute and 7-second video. But this one is their effort to take a picture of the biggest tree.
We photographed a 300-foot tall, 1,500-year-old tree that survived being cut. And it's the scientists that study these trees, this is their favorite tree. It's the most complex architectural tree on Earth that's known. But photographing it is nearly impossible. We spent a lot of time figuring out how to make this picture, and ultimately ended up raising cameras up into the canopy. We made it mechanized. We put 3 cameras on a dolly. There's a gyroscope. You drop it slowly down, and all of a sudden we're making a photograph. So what you're going to do is you're going to build a tree out of lots of pictures. It's nearly
So that's
impossible.
about it. I want you to look at this again. Look at the
Tree
people here.
survive
You see the
being
picture?
cut. And it's
There's a
the
person.
scientists that study these trees, this is their favorite tree. It's the most complex architectural tree on earth that's known. But photographing it, it's nearly impossible.
There's another person. I mean, it's just gigantic. It just keeps going. This tree is huge. Here's a third person, another person over there. It's just really huge.
Spent a lot of time figuring out how to make this picture, and ultimately we ended up raising cameras up into the canopy.
There you go. I just thought it was really cool to see this gigantic tree and all the different ways. So that's a redwood tree. They're really huge trees. Okay. So let's talk about it here. John found the data in the table below about his favorite redwood tree. He wondered if he could use it to predict the height of the tree at other points of time. Consider this as you analyze the data and answer the questions below. Be ready to share and justify your answers with the class. So we've got this table right here, and you see number of years after planting. So after planting the tree, 3 years after he planted it, he got this data, okay? And then 4, and then 5 years. And the height of the tree in feet, okay? So what we're gonna do is answer, please write, and you get 3.1.2 at the top of the page, and there's your problem 310, and this should be on the left-hand side of your paper. Here's the red line, you write 310 on the left of that red line, and then you write A, and we're going to answer these questions down here, okay? Actually, if you wouldn't mind, I do want you to go ahead and just make a quick copy of this table right here. If you need to pause the video to do it, do it. Don't make it fancy, just number of years after planting, 3, 4, and 5, and height of tree in feet, 17, 21, 25. So copy this. When you're done, unpause it, and we'll talk about it. Okay, so hopefully you copied the table, and we're ready to analyze it here. How much did the tree grow each year? Well, looking at the table, can you figure it out? This is year 3, and it was at 17. Year 4 was at 21. Year 5 was at 25. And if you look carefully, you're noticing every year it grows 4. So 4, and again, I want a complete sentence here. So for A, you should say, the tree grows by 4 feet each year. Okay, cool. So, based on that, can you do me a favor, please? Can you tell me how tall the tree, this is letter B, how tall was the tree 2 years after it was planted? And what about 7 years after it was planted? And how do you know? So please take a minute right now and go ahead and answer those questions. When you're done answering them, unpause it, and we'll check to see if you're right. Okay, now some of you maybe went back in your table and said, hey, if I'm going to go with 2 and I go back, every time it's grown by 4, so I'm going to go backwards and I'm just going to subtract 4. So at 2 years, it should have been 13 feet high. And then, 7 years. Well, 7 years, if I just extend my table, 6 would be 29 and 7 would be 33. So the tree would have been 33 feet tall. So you could have extended on the table. Some of you said, well, I just figured it out in my head and didn't use the table, just did it that way. That's okay too, but I do expect you to have written the answer as a complete sentence for both of those parts. So you should say, 2 years after it was planted, it was 13 feet tall. 7 years after it was planted, it was 33 feet tall. Okay, and then how do you know? I know because I extended the table, or I know because I added 4 to 25 twice, since it was 2 years later. You have to explain it, okay? And then, letter C, how tall was the tree the year it was planted? Now, automatically some of you are going to be like, well, 0, of course, because that was planted. However, sometimes you go to a nursery is not where babies are at, but a tree nursery is where you buy trees that are already a certain height. And so you buy a tree at a nursery and take it home and plant it. That's what happened this year, okay? Or with this case. So please figure out how tall the tree was when it was planted, and then estimate the height of the tree 50 years after it was planted. And this, guys, for letter D, this is an estimate. This is a prediction, so I want you to just kind of give it a guess. I'm not answering that question today, okay? So answer question C and answer question D, and then unpause it when you are done with those. Okay, so for question C, how tall was the tree when it was planted? If you keep working your way back, here it would have been, year 1 would have been 9. We needed to go to year 0 because that's when it was first planted. And if you go back 4 more, the tree was 5 feet tall. So for letter C, I do expect a sentence explaining that it was 5 feet tall. And then again, D, I'm not answering the question of how tall it was when you 50 feet tall. I'm not answering it. I'm just gonna let it go, okay? You should have that though, because we're gonna talk about it on Tuesday. All right, problem 311. John decided to find out more about his favorite redwood tree by graphing the data. On your resource page, that's the one in the packet, or those of you, it's the one provided here. It looks like this, okay? What you are going to do now is you are going to plot the points that represent the height of the tree over time, and then you're going to answer these questions. What does the graph look like? Does the graph represent a proportional relationship? Justify your answers, okay? And then you are going to answer questions B, C, and D. That is your work for this lesson. That is what I expect you to have done by the time you come to class on Tuesday, all right? So you're going to have this graph done. Please don't worry about the table down here, okay? Don't worry about it. Don't cross it off. I'm just crossing it out because we're going to work on that on Tuesday or Wednesday, okay? Or on Tuesday when you come to class. So don't worry about the table. Just worry about the graph right here. You are going to plot the points that we just put right here. Well, we plotted the points here, okay? So plot the points, and then you're going to plot them on your graph. Then you're going to answer these questions. What does a graph look like? Does a graph represent a proportional relationship? Justify it. Question B, does it make sense to connect the points? Explain your thinking. C, according to the graph, what was the height of the tree 1.5 years after it was planted? And D, can you use your graph to predict the height of the redwood tree 20 years after it was planted? Why or why not? So if you want to pause the video on this screen, you can pause it. Otherwise, you can go on your CPM book and just bring up problem 311. But for homework, you have to finish problem 311, including the graph. Cool? If you do not have access to a printer and aren't able to print out this resource page that I included on here, or if you didn't get the packet, well then just do it on a separate piece of graph paper, okay? And again, I'm gonna turn to it here so you can see it really quickly. That's how you set it up on your graph paper and graph it on that and just be done with that. Cool? Just make it that size, exactly that size, and go with that. Ideally, you just print it from there. So you can pause it here if you need to make the graph on graph paper. Otherwise, pause it here and answer these questions, okay? All right, that is all due on Tuesday when you come to class, so please make sure that is all taken care of. Have a wonderful whatever it is, whenever it is that you finish this, and I'll talk to you later. Bye.